After 3 try, he will take the same answer. Then we have something called residuals. After 4 tries, take the first 3 tries and do the same cycle. If you have multiple choice, it's hour. Yeah, because he can do every single question usually. They give you a set of 20 questions. Like he pick the one. Yeah, every Easter. Like yeah. Yeah, but like the self assignment, they will give you 20 questions. And if you have one wrong, it's multiple questions. And you submit it. After 3 tries of the same question, you put the same first answer. Yeah, everything.
All right. Can you guys see that okay?
I used that today.
Yeah. So I want to show you guys, if you haven't checked it out yet, and I thought it would be motivation enough to say that this will solve problems for you. WolframAlpha.com. It has, when I say Easter eggs, do you guys know what that means? Anybody?
Yeah.
Yes.
Like CDs very often have hidden songs, or games have hidden things in them. Wolfram Alpha has a lot of what's called Easter eggs, like what is the meaning of life? And of course, 42 is.
Can we turn off a few lights?
Yeah, sure. Can you? The one that says whiteboard, I think.
What does that mean?
Is that better? Is that all right?
A lot.
Do you want more? Yeah. All right, there you go. That's good. Okay. All right, now that's just playing around. You can do a lot of things like, how old would Einstein be when Mickey Mantle, let's see if it understands this, was born. They spell Mickey or 52 years, 7 months, I mean, just out of nowhere. If you type in your last name,
52.
here's my last name. It tells you how many people have that same last name, famous people with that last name.
What's that group?
I'm actually related to this guy. He wrote The Bridges of Madison County. I'm like his 28th cousin removed, come to find out. I'm not going to call him for any money. But here's the part that I think is going to interest us. This thing does, 1% of what it does is math. If you go to examples, if you're like in chemistry class, if you're in, well, freaking any class, I mean, look at all this stuff this thing does. So it gives you properties of elements. It tells you things about audio waveforms, historical periods. You can type in 2 countries and it'll compare the countries on a lot of different things if you're in some kind of political science class or something. This thing is insane.
Does it
So
work out the problems for you?
I'll show you.
Oh.
So if you typed in something like this, solve x squared plus x minus 7 equals 0.
How did you?
Oops, where'd my solve go? Do you see it gives you the answer? Do you see where it says show steps?
Yeah.
This is accurate? Completely?
How do you mean?
I mean, it's just always right.
So like Wikipedia for math.
It's have any of you ever heard of a program called Mathematica?
Yes.
All right, these are the same people that created Mathematica. It's running off of that system. What it will do, though, now obviously as a teacher, when I first heard about this thing, how do you think I reacted? Because I was teaching Math 110. So if students heard about this and they could type in all their homework one at a time and just copy down the steps. The funny thing is, it'll overdo a lot of problems. So you'll say solve this, and suddenly it'll bring in complex exponential functions to solve x plus 4 equals 7 or something. So then they'll write down some stuff, and I'll say, can you explain this to me? I've started to see that. I'm like, holy crap. I've seen people in the Math Study Center with the Wolfram Alpha up, and I'll come over to them and say, oh, you know what that do? All right, well, your teacher knows about it too, so be careful. So we're sort of in the same league as English now, because now you can get your English papers from online, and now you can get your math homework done online. A little easier than even, what is it, Chegg or Cramster or whatever these other things are, right? But here's what we just did. 1 divided by x squared was minus 10x. Was that right? Plus 24? Isn't that one we just did?
Oh, yeah.
Look at that. Looks sad. Oh.
Oh, whoa.
Yes, sir.
Try some fractions with negative exponents.
Oh, real quick. Everybody see now. I'll try that in a second. Here's the alternate form. So one alternate form is the factored form. Another one is interesting. This is something you guys will do. Actually, we're going to do this later this semester. Partial fraction expansion. It's kind of like taking this fraction and breaking it back up into its parts. So we'll figure out how to get those 2's. No roots exist. That's what we knew. There was no x-intercepts. It does a lot of stuff that we don't even know yet. Derivatives, integrals, those are calculus.
Oh, local max.
Local max.
Cool.
Insane. Here's what I was talking about. This symbol here is something you'll see a lot of when you get to calculus. Blah, blah, blah. So what was it you wanted to see? Sorry?
Fractions with negative exponents.
So like 2/3 to the negative 3?
Yeah.
Why does it show 2 graphs?
Oh, this is a different scale. See x from 4 to 6, x from 0 to 10.
Oh.
So just a different scale. And real quick, if I did 1 divided by, if I said this, plot 1 divided by x squared minus 10x plus 24, x equal negative 5 to 5. Let's see if that understands that. Yeah, there we go. So the nice thing with this is it's always improving. Every Tuesday, I think, they update it. They add suggestions. There's whole forums where people can say, can you make it do this? Can you make it do this? Can you make it do this? So they're continuously improving also its interpretive ability. So you can type in a sentence, and it'll try to interpret it. It will sometimes get it wrong, and so you just try to type it in a different way.
Oh, one more thing. If you submit feedback, you say you want this feature, they will email you back when they add that feature.
Exactly. Cool. I mean, these people are insanely cool, and it only makes sense. These are people that are interested in making this thing a lot better, because they want this to be like the one-stop shop for an informational database, really. So what did it do here? So it plotted this, but only from negative 5 to 5. And of course, that turns out to be kind of a bad thing, because where was the other vertical asymptote? Was at 6. But you can control the domain where they graph it. You guys with me so far? Okay. So real quick, let me try what you're saying, because I don't think I've tried that yet. Like 2/3 to the negative 1/3?
Yeah.
See if it'll understand that. Cool, man. All kinds of weird stuff. Is this what you were expecting, or?
The one from the quiz, if you enter that one in, that has fractions in fractions, it has a very hard time with that one.
Oh, okay. Oh, it takes it a while?
Yeah.
Yeah.
And then it has an awkward answer.
All right, I understand. Anyway, so if I were you, I would play around with this thing. Some of you guys, I don't know if you're going to try to just start typing all your homework in and letting it do it for you, but hopefully you understand by what I just said. I know what to expect from Wolfram Alpha, so if I start seeing all of your problems saying what I would expect this to say, that could be a problem. But at the same time, homework. Oh yeah, Web Advisor's down, by the way, for some reason. It's still down. Homework counts so little at the end that cheating on it makes no sense. So that's why I have no problem showing you a website that can do all the work for you, because if you do that, you're going to fail the class anyway, right? Wolfram Alpha, get your A. But you won't. But if you use that right, that website's stupid awesome. I mean, if you have really a lot of trouble on a problem and you get somewhere, you can go to that website and kind of see where what you've done matches and where you went wrong. It'll show you the steps to solving a problem. It's insane. Okay. Can you turn the lights back up? Thanks. All right. So guys, if I went back to where we had this, and it's just this here very quickly. Is that cool? Where's the horizontal asymptote? Remind me.
0.
I like it. So the horizontal asymptote is y equals 0. Cool. Because that's what y has to do eventually as x gets really big. When x is small, y can do whatever the hell it wants to. When x gets big, it better start going towards 0. That's what a horizontal asymptote means. It only has to approach that thing when x gets really big, positive or negative. Okay. Bless you. How could I make that horizontal asymptote actually move? Because if I make this move left and right, do you see how that horizontal asymptote doesn't care? If I just make it move left or right, the horizontal asymptote is like, I go to infinity. You can move me this way as much as you want to. I'm not going to go anywhere. How can I make it move up or down?
Add or subtract.
I like it. So I can make a function maybe like 1 over x plus 2 like that. So what would that look like? Where would the horizontal asymptote be now?
Y equals 2.
Yeah, it goes up 2. So there's the horizontal asymptote. And now it's basically going to have the same look again like this. Like this. Notice, of course, that now it has an x-intercept. Because now it's allowed to hit the x-axis. The horizontal asymptote's moved up. What number would that be? And again, my scale doesn't give anything away. I don't know what my scale is. Here. So all I got to do there is 1 over x plus 2 equals 0. 1 over x equals negative 2. Flip both sides. X equals. So that would be negative 1/2. That's that. X-intercept. Is it? Everybody with me? So this is not the way it's going to look. This is the most immediate way I can make the horizontal asymptote be something other than 0, right? I just have to move the damn thing up or down. Not a big deal. What you're going to see it as is these two combined. Take a second and please add those. Don't tell me you can't. Do it. What's 1 over x plus 2? Do it. You guys can do it. What's 1/3 plus 2? Don't say 2 1/3. That's fine. I'm waiting for somebody to go 2 and the next. No. They're not LCD there, right? All right. So what do you have to multiply him by? X. So you get 2x plus 1 over x. So if they give it to me in that form, how could I see that the horizontal asymptote is actually 2? And the funny thing, I'm going to tell you a couple different ways to think about it. I'm going to tell you the way that always works, and then I'm going to give you kind of a shortcut list of 3 possibilities. And either way you want to look at it is cool by me.
Separate them.
Yeah, you could just separate it back out.
And then cancel out.
Now, of course, if the bottom was x minus 1, could you just separate them? No.
No.
But you could, more generally, you could just long divide these. Right? In this case, so it'll be x into 2x plus 1. And this go twice. And there's nothing here, right? So you got a remainder of 1. The important thing is that the whole part of that is 2. Plus 1 over x. Isn't that where it came from? You guys with me? So when x gets really, really big, what happens to this 1 over x? It goes to what?
Infinity.
Careful. When x gets really, really big. So 1 divided by really, really big is really, really small. So let me make this a little more formal. As x goes to infinity, 1 over x goes to 0. Definitely. cool. So if I long divide this thing, whatever this piece is going to be the horizontal asymptote, because the other piece is going to be the remainder. It's going to go to 0. So when x gets really, really big, this must look like 2. So what's happening when x gets really, really big? What does it look like up here? Does it start to look like 2? And back here it starts to look like 2? Okay. All right. So what if we have a little more complicated one? Because back there. Now, my first question is, what would the horizontal asymptote be? Now, if you try to long divide this thing, can anybody tell me what trouble you run into immediately?
Trying to divide x by
Yeah,
x
you have a
squared.
higher power of x trying to go into a lower power of x. Will this go into this at all?
No.
So isn't it 0 plus the remainder of this over that? You with me? Sort of like if I said make 7/8 into a mixed number, you go 7/8. It's 0 and 7/8. There's no whole part to it. So where's this thing when x gets really, really big? This thing is going to go to 0. A much more direct way to think about it. Here we go. I'm going to try to give you both ways at once, and then I'm going to give you the list of 3, which is where everybody kind of goes to as teachers. I want to show you really what's going on here. When x gets really big, which one of these is growing faster, the top or the bottom? I heard a few TOPs. That's not good. The bottom is obviously growing faster, right? Because it's squared. So the top is only triple. Square is going to kill that. You with me? In fact, if I put 1 billion here, 1 billion to the billionth power x plus 1, this will still kill that eventually. So when x gets really stupid big, the bottom is just so much bigger than the top. If the bottom's getting bigger and bigger faster than the top, the whole thing is going to 0. So whenever the bottom power, I've slowed down now, this must be a note. Whenever the bottom power is larger than the top power, it's going to have a 0 asymptote. Because the bottom is going to crush the top. It's going to just kill the whole fraction. It's going to go so big, so quick, this is going to just, the whole thing is going to go to 0. Okay. So whenever the bottom power is higher than the top, the degree, right? The highest power. So this is a second degree, this is a first degree. That's going to have a horizontal asymptote at 0. So this guy's horizontal asymptote is y equals 0. Whenever they're the same degree, this is where it's a little more interesting. If they're the same degree, is either one of them growing faster than the other one? No. So it actually ends up being just the ratio of the coefficients. And I'll show you a little bit better reason why. Don't worry, I've got a little handout that's got these 3 things we're talking about. So here's one thing. When the bottom is higher than the top power, it's going to be y equals 0. Bottom power greater than the top. When they're equal to each other, I'll give you another situation. Okay, bless you. Let me show you the way that's shown very often. First, let me just fall back on what I was saying earlier. If you try to do long division, and I know that a lot of us don't like it, but I'm going to give you shortcuts to do this. I'm never going to make you do this long division, but I want you to realize that it's built off of this. 5x squared goes into 2x squared how many times?
2.5.
Yeah, 2.5.
2/5 times. Right? Because what's 2/5 times 5? Yeah.
2.
Right? So there, I don't know why it's always made such a big deal. 5 goes into 10 how many times?
2.
Because 10 over 5 is 2. 5 goes into 2 how many times? Well, what's 2 over 5? 2 over 5. All right, there you go. It's the same thing we do here. It's so easy here we don't even realize what we did. But we do the same thing there. It goes in 2 over 5 times. So what's the horizontal asymptote of this going to be? It would be a remainder here, right? All right, let me do this out for real. Oh, this is kind of a gross one. Good job, Jeff. Let's see. 2/5 times this is 2x squared. 2/5 times 6 is plus 12/5 x. 2/5 times -2 is minus. You can do it, Jeff. Maybe you can. -8/5. Something like that. When you subtract these, you change the signs. Those go away. You get -32/5 x plus something or other, 43/5. Are you guys roughly with me? Don't let the fractions freak you out. We can focus on the fractions. That's not the big deal. The big deal is what I end up here is I get this over this as a remainder. Cool? It's going to be the remainder. Now what's happening with the remainder? When x gets really big, isn't this bottom higher than the top? So this whole thing's going to go to 0. So when x gets really big, this looks like 2/5. So when the powers are the same, the horizontal asymptote is going to be a ratio of these. And look what we did. Here, we knew that horizontal asymptote was going to be a 2 because we forced it to move to 2. And what's the rule? Are they the same power?
Yes.
Yeah. What's the ratio of the coefficients? 2. Right? 2 to 1? Yeah. So there's the 2. So when the bottom power is higher, it just kills the whole thing. It goes to 0. When the powers are the same, it's the ratio of the coefficients. Now I'm going to have, so if I were going to graph this, which we won't because that looks pretty damn disgusting, where would there be a horizontal asymptote? 2/5. So at 2/5, there would be a horizontal asymptote. And then I can go from there. Okay, so what's the one situation we haven't discussed yet? I've done the bottom power higher than the top. I've done the powers the same.
The top higher than the bottom?
Exactly, the top higher than the bottom. So I'll tell you what, before I do that last one, because that's the freakiest one, I want to get to the point where I can give you this little handout. Actually, I might be at that point. Yeah, let me do this. See if you guys can handle this. So on part C on this, in that little box, I've got the rules for horizontal asymptotes listed out.
Is this all still 3.7?
Still 3.7, yeah. Thing is chock full. Yep. What's that? Oh, the next one would be the top power higher than the bottom. That's the one thing. Oh, October 1st, yeah. And this will be on there. Oh, yeah. Definitely.
Chapter 4?
Oh, yeah. There'll be some in chapter 4 on there, too. All right, so. I want you to try to do as much of this as you can. So look at 1C real quick. You see the box? It says if the degree down below is larger than the degree on top. I just didn't feel like writing denominator numerator. Y goes to 0 as x gets large, so your horizontal asymptote would be y equals 0. Right? That's what we were just saying a second ago. If they're the same, the top and the bottom are the same degree, the horizontal asymptote are the ratio of the coefficients, like that 2/5, or the 2 one that we did earlier. And then part 3, don't worry about it. We'll do that in a minute. That's not happening on this problem. Number 3 is where you get something called a slant asymptote. Which sounds exciting. But do what you can for this, and you can work together if you want to. Oh, yeah, sure. this full circle. There's a Wolfram Alpha app for phones, and this is one reason why I don't let anyone use phones anymore on tests. Because that's really useful.